Hello and Namaste. In continuation with the successive differentiation, we are going ahead with the part 2 after the detailed and five different types of questions in the part 1. We are going ahead with the part 2. So we are dealing here with the different questions than what we have dealt in the part 1. Find yn if y is equals to 1 upon x square plus a square. That means we have to go ahead and write down this 1 upon x square plus a square as equals to 1 upon x plus ia into x minus ia. That means what we have done, the factors of x square plus a square as x plus ia, x minus ia, which we can go ahead and do it here as a upon x minus ia plus b upon x plus ia. If I need to have this factor a is equals to, so what would be that? If x is equals to ia, then putting the value in the numerator, but we do not have anything x in the numerator, so we have to put it here, don't have to put it here, which is we are going to get it the value as 1 upon 2ai as the value of a. Similarly, to get the value of b, we have to have f x is equals to minus of ia, then we will be getting the value as we are not going to put it here, but we are going to put it here. That means we are going to get it 1 upon minus 1 upon 2ai as the value of this particular b. This is by our hiding method, which is just one line partial fraction. Y is equals to 1 upon 2ai. That means we have taken this 1 upon 2ai out. After writing this up, we have got it 1 upon x equals to 1 upon x minus ia minus 1 upon x plus ia. That is nothing but we can have this particular formula. If y is equals to 1 upon x plus b, then yn is equals to minus 1 to the power n, a to the power n factorial upon ax plus b to the power n plus 1. We are applying the same thing here in both the cases, that is 1 upon x minus ia and 1 upon x plus ia. We got this as particular thing. Taking this minus 1 to the power n and n factorial out along with this 2ai, we are going to get this particular factor. But here we have got the factors as 1 upon x minus I to the power n plus 1. So we can just go ahead with the de Moivre's theorem, and to apply that we do have to put some substitutions. So we are putting a substitution here as x is equals to r cos of theta. That means the real part is equals to r cos of theta, and the imaginary part. Now what is the imaginary part in this two conjugates of each other? We have got the imaginary part is small a. So small a is equals to r sine of theta. After going ahead with that, so r is nothing but square root of x square plus a square, and theta is tan inverse of a by x, that is y by x. This is nothing but we can follow it using the de Moivre's theorem. Please follow the I button so that you can follow this de Moivre's theorem in detail from the complex numbers playlist. Then yn is equals to minus 1 to the power n and factorial upon 2ai. Now this is nothing but 1 upon r cos of theta minus I times r sin theta to the power n plus 1 minus 1 upon r cos of theta plus I r sin theta to the power n plus 1. Converting this particular thing, or you can just say it here, that is r, we have taken it out. If that r is coming out from both the brackets, it is coming out as r to the power n plus 1. From both of them we have taken it out. Then we have got it here as this particular factor. I have purposely kept the same step what we have done it the last as a last step. So that means we have converted this. It's up to you that whether you wanted to convert this into exponential form or whether we are just going ahead with the same thing. So if we are converting this e to the power cos of theta minus I times sin theta as the exponential form, it is giving us e to the power minus I theta to the power n plus 1, and this cos of theta plus I sin theta is nothing but e to the power I theta, which is n to the power n plus 1. That is nothing but this is nothing but my e to the power minus I n plus 1 times theta, just an adjustment to have it, and then we can take it in the numerator. While taking the numerator, this minus becomes plus and this plus becomes minus when it is coming up in the numerator. Again, going back to the cos and sin theta over here, so you can just check it from this particular step, that this cos of n plus 1 theta and cos of n plus 1 theta minus plus will go off. You will remain here with 2i sin of n plus 1 theta along with these factors which are there outside the bracket. That means, but as a is equals to r sin of theta, which is a substitution we have taken it for the imaginary part, r is coming out to be a upon sin of theta, and that we are going to replace it here and we are going to get the value as, so this is minus 1 to the power n factorial. This r is getting replaced as a upon sine of theta to the power n plus 1 sine of n plus 1 theta. Now if you will observe here, this 2y and this 2y will go off from here from the previous step, and therefore we will remain here with the answer minus 1 to the power n factorial upon a to the power n plus 2 sine to the power n plus 1 theta sine of n plus 1 theta for this particular question. Now this type of question we can, so what concept we have used it here? We have used the concept of De Moivre's theorem to reduce it to this particular yn or nth derivative of this particular function. Let us consider one more similar type of question. So if find yn if y is equals to tan inverse of x, so we know that directly we can't apply the nth differentiation or nth derivative of this function tan inverse of x. So we have to take one step here, that is differentiating with respect to x. If we are differentiating with respect to x, we are going to get is 1 upon 1 plus x square, which is again can be splitted as, or you can say the factors as 1 upon x plus I, x minus I, which is we are going to get it. Now we have got it because we have been told to find out the nth derivative, and we have already at first stage. So if we are taking ahead, we are taking this particular steps over here, and I wanted to reach here the yn, and we have at one first step. So how many number of steps we are remaining here with? N minus 1. So we have to take it here n minus 1th derivative of this particular function. That is nothing but yn. So 1 upon 2i, this is nothing but the n minus 1th derivative we are taking for this particular function. If we are taking the n minus 1th derivative of this particular function, that means at this particular formula, you have to replace every n by n minus 1. You have to replace every n by n minus 1. So what the formula becomes here? So yn minus 1 is equals to minus 1 to the power n minus 1, a to the power n minus 1, n minus 1 factorial upon ax plus b to the power. N will be getting replaced as n minus 1. So plus 1 minus 1 will go off and you remain here with n. This is what we have written it over here in this particular formula. So just a little bit of modifications we have to do it here in the given formula or nth derivative, depending upon the demand of the question. So it's yn, we have got it here. Similarly, so we have taken this, the common factor minus 1 to the power n minus 1, n minus 1 factorial and 2i. We have taken it out and we have remained here with this one. Again, the same type of substitution we have to go ahead with, because here we have got the 1 times I. That means what we have to, this x will remain the same, x is equals to r cos of theta. 1 is getting equals to r sin theta. That means what? Imaginary part is equals to r sin theta, and therefore r is square root of x square plus 1. Theta is tan inverse of 1 by x. And we have this yn is minus 1 to the power n minus 1 and minus 1 factor upon 2i into this. The same thing we have done it. What we have done in the last step, we have taken r to the power n out from both the brackets. We are going to the exponential terms. After going to the exponential term, we have to take this exponential term in the numerator. So minus becomes, this particular minus becomes plus over here, and this plus becomes minus over here. Again going back to the cos and sine terms, and this cos n theta, sine cos n theta will go off from here. You'll remain here with 2i sine of n theta. Again 2i is getting off from here, and you will remain here with, because 1 is equals to r sine theta, r is nothing but 1 upon sine theta, and we are going to get this particular factor because we are replacing this r as 1 upon sine theta. If we are replacing this r as 1 upon sine theta, the final answer becomes minus 1 to the power n minus 1 factorial sine to the power n theta into sine of n theta as the particular answer for this particular question, tan inverse of x. So these are the different type of questions which are very important for the successive differentiation. And I have not given the successive differentiation with the extra questions, but definitely I'll be sharing few more questions in the description section or might be in the comment section, so that you can just follow it up with the extra questions and a practice question. I hope you have understood the successive differentiation in detail. Thank you. Happy learning.